I'm really excited that you all were able to join us here at Airbyte for their event with Snowflake. It's going to be an awesome time. I'm going to pass it over to one of the leading organizers for this. This is Sean. He's awesome, and walk you through what you can expect tonight and do intros. Thanks for being here.
Awesome, thank you, and also thank you to Airbyte for hosting this event tonight. So thank you. Let's get a round of applause for Airbyte. All right, so as I mentioned, my name is Sean Faulkner. I help run the Bay Area user groups for Snowflake, but I don't work for Snowflake. That's often a common misconception. But we have some really, really awesome talks tonight, all focused on Snowflake's Cortex and sort of different uses of it. How many people here have used Airbyte? Anybody a user of Airbyte? See a few hands. What about Snowflake? More, yeah. What about Cortex? Has anybody played around with Cortex? Awesome. Thank you. All right. So first up, we have AJ Steers from Airbyte. He's going to talk about essentially, well, I won't steal his thunder, but powering Snowflake Cortex using Airbyte. So let's give him a hand of applause. We're going to have a few minutes for questions at the end, and we'll kind of move through these things. But there'll be plenty of time to ask everybody questions as we move through that tonight. But thank you.
Thank you. Thanks, Sean. And thanks, Snowflake, for being here. This is really exciting to... here we go. To be talking about what you can do with Cortex and what you can do with Airbyte and these tools together. So as mentioned, I'm AJ Steers, and here's what I'm going to be talking about today. So first, I know that not everybody's hand went up when we said, have you used Airbyte before? So rather than just talking about like what to do with Airbyte, we'll talk a little about what Airbyte is. Specifically AI features, we'll get into some of those. I'll do a demo on how you can get data into Cortex without writing any code and just using Airbyte. And for those of you who have approached that problem before, you know there's some sticky parts such as chunking, text splitting, embedding, things like that. We'll show how that really becomes very easy. And then we'll end with breaking down silos between our coders and non-coders. Who's on Team Coder right here in this room? Team non-coder. Ooh, we got like a 40-60 split. Slightly more coders. All right, this is going to be spicy, but no black eyes, promise. All right, so where am I coming from? I'm a data guy. That is the one thing that I have identified as throughout my career, but I've done a bunch of different things. I started off at BNP Paribas, actually Bank of the West, on Montgomery right here. And I went to Amazon and had an amazing stint going from data warehousing and BI to data engineering at epic scale. And then after 2 years in EC2, building up a BI team in EC2, I went to Amazon Video and ran data engineering for Amazon Video. This is right when we were starting to become a name that people knew. So it was a very exciting place to be there and built some really big data systems. I went into consulting and startups after that, and I've really loved, I loved that, and that led me into the open source world because consultants just help people build stuff. We're on YouTube. We just help people build stuff, and being able to bring those architectures that I had done for Amazon or big companies, bring them to small companies, universities, things like that was always very fulfilling for me, and that led me directly to working on first Meltano and now Airbyte. And I couldn't be more happy to be building the product that I wish I had 5-10 years ago at the small and the big companies. I just want to share that journey with you before we get started. All right, so what is Airbyte? Gets data from the left over to the right in the data flow diagram. That is like oversimplification, but basically moving data from any source to any destination and doing so resiliently, quickly, in a way that you can trust and rely on and go to sleep and not think about anymore. Just know that your data will show up the next day. We are built on open source, which means that we have more connectors than even we can name. People are building connectors for themselves on our platform all the time, and then periodically they get fed back into the community, into our library that we support. So it's a very large set of connectors, and it's a community where the community is supporting itself as well as we are supporting the community. We've been doing a lot around AI the last year and a half, and this has been my baby a little bit, so it's close to my heart. Come talk to me later about it if you have any questions. But basically, we wanted to be able to get all of the data that you didn't used to think of as data, like I don't know, Trello or tweets or Google News or LinkedIn posts or team documents, PDFs, Slack messages. That didn't used to be data before AI came around because there wasn't anything you could do with it. You could count them, how many messages came through, but you couldn't get information from it. You couldn't make it actionable. So we set about to make sure we could get data from any unstructured source that you could imagine into the same pipelines that you would for traditional tabular data sets. And we set about making sure that we could load data into any vector destination or vector store so that your AI has a long-term memory filled with those things that you want it to know about. And thrilled for Snowflake to join as a hybrid like SQL platform plus vector capabilities. And they're going to talk more about that. I'm not going to go into all the details, but like this is huge. Like databases just being able to do vector stuff and AI stuff is huge, and I'm really excited. I was thrilled when Snowflake was announced. We got a little preview before it was publicly announced, and we got to kick the tires early on, so it's been something we've been really excited about. All right, so with Airbyte, like I mentioned, we do have a very big community. I won't read all these stats to you, but I will mention just we have a huge number of sources. I think it's actually more than that now. And we're migrating more and more sources from our Python system over to our no-code YAML system. If you don't know what YAML and Python are, great, it doesn't matter. But if you do, you know that like that's a level of abstraction that like makes support costs go down. If a connector is defined by YAML, it's easier to support, it's easier for others to contribute to, and we have a UI around it that just makes it really easy to edit and improve as people go. All right. Here is just a quick overview of what I'm going to demo when we set up a Snowflake Cortex destination. And it basically is just a friendly UI where you can configure connection to Cortex and then throw any data into it. All right. Things that you will not necessarily think about until day 2 or day 3, but like they're really important, they're here. We have change data capture, incremental processing, meaning if you have 10 terabytes of data and you sync it once, and now another terabyte shows up over the next month, you don't have to resync the 10. You just get the one new terabyte or whatever the volumes are, which means that your syncs are going to go faster, you'll be able to keep up with larger scale of data, and your costs are lower. A lot of data replication code that you might write yourself won't have that feature up front. You say, oh, I'm going to write some code, I'll copy some data over, but you won't have incremental processing up front. You might not have deduplication up front. We have all of that built into the protocol, and it's just there from the ground up. On the AI side, I don't know if everybody in the back can read this, so I'm going to kind of call it out. Who knows what like chunking and embedding is? Ooh, a lot of you. That is fantastic. Okay, so for anybody who doesn't know what chunking and embedding is, it's basically taking a very large document and 1, breaking into smaller documents, chunks, and then 2, embedding those or calculating embeddings for those, which is a numeric representation of each chunk. So with that numeric representation, that embedding or that vector, you can do some really cool things, and that's where AI, how AI search and vector stores are working. So normally you have to write code to do that, but with Airbyte, we have that built into every vector store that we have, and all of our unstructured data sources also parse things like PDFs, Google Docs into standard Markdown. So it's just simple by default. You can get all of the data semantically interesting ways, chunk it however you want to with best-in-class like chunkers, chunker splitters, text embedders, all those things, and you can use any embedding service you want. Okay, cool. So that's all just built in. Let's see it. So here I'm going to go over to my Airbyte instance. I'm going to bump the font up as much as I can, hide my sidebar, and let's go back to sources. I'm going to create a new source, bump the font a little more. All right, so in this case, I want to get data from GitHub. Specifically, I want to get issue descriptions and comments on issues. So here's what that looks like. Here's my GitHub repo, and you can see I have a bunch of issues, and each one has a description, and some of them have comments. So I want to get this as data into Cortex so that I can ask questions about what people are raising issues about, so I can find similarities, so I can maybe direct users to common issues that have already been reported when they come up with something new. All right, so how am I going to do that? I'm going to just say new source. I'll type in GitHub. This is where I have to do with one hand. So luckily I don't have to type very much. So here the source name is GitHub. Let's say GitHub issues and comments. And what's cool about Airbyte is that almost all of our sources have OAuth. And since I'm already actually logged into GitHub, that was, if you blinked, you missed it. I clicked login, and it logged in. Now, it would be one extra screen if I hadn't done that before, because GitHub asks you if Airbyte has permission, but yes, I've already granted permission. I click the button and it's authenticated. And now I just type in the GitHub repositories. And that's it. So I'm actually going to switch over to a connection I already made that has that same thing. Here is the GitHub issues, comments, and discussions going into Cortex. Let me show you how Cortex is defined. I'm not going to type this in because I want to keep this moving, but you could kind of trust me that we could type this in if we wanted to. So Cortex, we can name this anything we want. Chunk size, again, that's just typing in what chunk size you want to use. And then which fields you want to treat for text embedding. You just type them in, separated by a comma. And then choose if you want to separate text by separator or by markdown header. Since I'm doing this extraction from GitHub, and not every GitHub, I'm not relying on it to be in proper markdown format, I'm just going to select the separator. But I could select by markdown header or by programming language, and then it will use those splitting logics. And so you can see what the default separators are. Okay, so that's fun, but on embeddings, we have an option for fake if you just want to do a dummy test. We have an option for several embedding options. Right now, we don't yet support the Snowflake LLM embedding, but that will be coming soon. Right now, you can pick OpenAI, Cohere, Fake, Azure OpenAI, or OpenAI compatible. And that's really anything that's, pretty much everything is OpenAI compatible now, so you can run any embedding service through here. And then an API key, and that's it. So the last thing we'll specify is our Snowflake connection information, and that's it. So let's go back to the connection, and I'll just show you how we run this. So we're going to sync now, and it will just take a few minutes. It will sync over these two streams. And they're syncing to Snowflake, but they're syncing to Snowflake as vectors. So what we're doing is we're extracting data from GitHub. We are passing that on to the Cortex destination. We are grabbing those fields that were specified as text, title, body, comment. I think those were the three that we specified. Those are going to be automatically collected together as a document body, and they're automatically going to be split if needed. They're all going to be looked up against the embedding service I provided, and that output is going to load into Snowflake. So I have run this already, again, in the interest of time. So let me just show you what that looks like. Again, I'll bump the font size up. But here we have two tables, comments and issues. And if I select from issues, I'll see that we have data already loaded. We have a document ID auto-generated, a chunk ID auto-generated, the metadata fields that might be relevant after you found a match. So, okay, find me all of the issues related to vector store search. Okay, that's a little bit meta, but we could do that. And then once we have that list, we would use this metadata to dereference them. Oh, this is the issue number. This is the person that created it, et cetera. And the document content is here. So you can see the body is concatenated together. And then the embeddings here are, it's an embedding, if you're new to this, embedding is just it's an array of floats, just a bunch of numbers. A fixed length array of floats is all it is. It's nothing magical. But this uses the new vector type in Snowflake so that you can query this directly as with some of the cool things you guys will see from our next presenters. So I'm going to switch back, but any quick questions before I leave the demo? All right. All right, so now let's talk about coding and coders and non-coders. I think we had it said it was like around 60-40 split, or actually there was some overlap, so maybe 60-50. The 10 of you are choosing both camps. So as a developer, a software developer, since I was in junior high, I just got a book and learned how to read it. I've always loved to code. But when I became a manager, I realized that like all the code that we wrote is code we had to maintain. So there is this like push and pull of like how much code is the right amount of code, and how do you enable everybody to be successful without creating silos. So I like this saying, everything should be as simple as possible, but no simpler. And that's the approach that I take. If you are an engineer and you have to write code, let's get you a way to write code you can trust and ship. If you are not wanting to write code, let's give you a tool you can use so that you can be effective without having to jump into writing code. So just enough code is what I like to have, meaning that I have just the right amount of code to give me control and iterate quickly, but not so much code that nobody's going to want to touch this when I'm done with it. And I've seen that so many times. One engineer spends weeks and weeks on something, they go on vacation, and nobody knows how to support that code because it's just too much code. Sorry. It is, sometimes. So here's what we try to do with Airbyte. We make available hundreds of source connectors, but you're not writing the connectors from scratch. You're calling them, just as you would with the Airbyte service. You have the ability to create your own source connectors with no coding. I mentioned the YAML interface and the UI builder, but there's still code behind it. That YAML is an artifact you can put in Git if you want to. You can pip install Airbyte, including in Google Lab. We've not tested a bunch in Snowpark, but in theory, you could also install in Snowpark. And you have your choice of production deployment. You write the code, it works great. 3 months later, 5 months later, your boss wants to put it on a production cloud server, we can put it up to cloud. And you don't have to rewrite it from scratch. And all the code you wrote downstream from that data movement doesn't have to be rewritten either, because the data shape and the replication process is the same. So this is great for hobby projects and prototypes. It's great for large-scale applications. And there's always a clear handoff path to IT and data ops teams when you're done. Whether you write it in code or whether you do in the UI, you're set from there. So I'm not going to go too deep into the code, but I just want to show you a little bit of code. Import Airbyte as AB is a just convention. If you want to see the list of connectors, there's a command to do that. And you just call get source with the name of the source, and you'll get the source object. To configure it, you pass in whatever the credentials are that this specific source needs. And again, this is generic for anything. It could be GitHub, Slack. Everything has the same paradigm here. Every connector has a check method, so you want to make sure your credentials are right. You didn't mess up the config. And then finally, you can check what streams are available and then read them. So just source.read, again, optionally specify the streams you want, and then you're off running. If you're a Pandas person, anybody use Pandas here? Yeah. Anybody prefers SQL over Pandas? Some people, cool. And anybody used LangChain yet? Yeah, okay, cool. So we have interfaces for all of those, as well as for Arrow, if you've used PyArrow. And we made this as simple as possible. Again, it's just 2 pandas. You have the data set you collected and 2 pandas, 2 SQL table, and 2 documents. And you might ask, those of you who are paying attention and like having some experience on SQL, how am I getting a SQL table from this? All we did was read. Well, there's this thing called DuckDB, and it's just a very, very scalable SQL database that can run on your file system. So if you don't specify another place to send the data, we throw it to DuckDB locally, and you do have a SQL table behind that, just magically. So that is available, and you can take advantage of it. Like I said, full control with not a lot of code, and we just added support for destinations as well. So caching is what I mentioned, that automatic thing that happens in DuckDB, just so we can quickly get you the data and you can use it however you want after. But you can also get a destination and send data to destination with a write command. We try to keep these very simple. Read to get data out, write data to send data in, and Yeah. So if you are in the coding camp, we hope that you'll give it a try and give us feedback. We're still in beta, but we're trying to bridge the gap, especially for AI developers. We know you're reaching for a library a lot of times, and you want to iterate on code quickly. So this should be an answer for you in those scenarios. And then when you're ready to productionalize, you of course have a path to do that. So here's the Airbyte family. Airbyte OSS, install anywhere with Kubernetes. Enterprise, same thing, except you have production support and other features. And then cloud is if you just don't want to deal with infrastructure at all, you just want to pay somebody to run it for you, that's where we come in. And now PyAirbyte. So if you just want to run Python, you've got that option as well. PyAirbyte also integrates with all of these, so they all kind of play well together. And whatever data you want to get into Snowflake for analytics, you can get it through here. And again, not a lot of code or not a lot of clicks, whichever you prefer. We're really trying to break down silos so that one team doesn't say, oh, I'm going to write this by hand in my favorite coding language. And so another team says, oh, I found this real cool GUI app, but it only works on my laptop. This is a tool that every team can use. Data engineering, machine learning, Gen AI, data warehouse analytics. Everyone can be sourcing with the same connectors and the same paradigm, even if you're taking different approaches to that extraction and data movement. So you can parse your docs, scrape the web, tap your apps. You can load to data lake, data warehouse, data vector store. You can orchestrate with the cloud, the self-managed, or just directly in Python. It's looking good. And with that, any last questions, and we'll hand off. Yes, in the back. I'll try to remember to repeat the questions for those. Yeah. Yeah. What's the question? I don't know if we have that stat handy, but a lot, a very, very lot. We test with terabyte scale, and we have people who are moving very large amounts of data. So yeah, we design for large scale. Is PubSub the right mental model for Airbyte? I don't think of it that way, because there's not like a channel or a post. It's not Kafka where you're just sending to an always-on stream or SQS or something like that. It is we run it on the frequency you need to match the latency you want, and when it's not running, it's not costing you anything. And that's a big difference between that and a lot of PubSub architectures where you're constantly having to pay for the infrastructure that you need at the max peak that you will need it, or hope that you scale in time, whereas this is just running at the frequency you need to keep your data up to speed. Other questions? Yes? Oh, what about multimodality? I love that question. So there's really two classes of, and specifically related to images, there's really two classes of sources. Those that we built to parse into Markdown, as I mentioned, and we have a special parser for that. And those where we receive the data directly from the source, like the GitHub API. So the GitHub API we're not secondarily parsing that result to get data from the images. However, if we're talking about a PDF, we are doing that. So PDF might have images, it might need OCR itself, and that is being scanned. And if you, let's say, run it on Google Slides, that can also be scanned for your images to have a text extracted from them. Yeah, does that answer your question? Sweet. Okay, here we are. Arun? Do you need power?
That was amazing. Thank you, AJ. Hi, everybody. So nice to meet you all. My name is Arun Agarwal. I lead the AI product marketing team at Snowflake. This is one of my first meetups in the city. I'm super excited to be here. Had I known they have free pizza, I would have come here earlier. Okay, so the goal today is we have two speakers, myself and Octave. He's an engineer. And what we'll do is, my goal is to give you a sense of generative AI at Snowflake, how we think about Gen AI, what are the different elements. And then I'll pass it on to him to kind of show us some cool demos and kind of get into the product. Okay, so before we get into the details, this is just a lawyer statement. Please make all your decisions based on information that's currently available. Don't trust me, trust what's on the website. Okay, so here is what's going on. So there's been a lot of things that's been happening, both on the generative AI as well as on the machine learning side. And at Snowflake, we have been thinking about it as one unified platform. So what we are doing is at the bottom, we have this unified governance layer that helps you kind of manage your models as well as your data. And then on the top layer, we have this development layer, which helps you quickly make apps. You can use the no-code AI Studio. You could use notebooks. There's this feature called Streamlit to quickly start making use of Gen AI in your organization. And in the middle, we have generative AI as well as machine learning. Everything we talk about in terms of generative AI at Snowflake is under the Cortex brand, okay? So the 3 principles that guides us at Snowflake around Gen AI is it's easy, it's efficient, and it's trusted. It's easy because it's a fully managed service, so you don't have to worry about managing infrastructure or managing GPUs. We do all that for you. It's efficient because we bring your data and your model next to each other so that you can run your Gen AI quickly. And it's trusted because we build a lot of thought into how we have created this Gen AI product, and thousands of customers are already trusting Snowflake with their Gen AI work. Okay, so let's double click into the easy and efficient messaging here. Why do we say it's easy and efficient? This is the overall architecture of the different elements that we have in Snowflake. So if you start at the bottom, we have a lot of open source models. We have models from Meta, from Mistral, from Reka, our own model called Snowflake Arctic, if anybody has tried that. So those are the foundation models that are available in Snowflake Cortex. We also offer you the ability to fine-tune your models in case you're not happy with the way your models are working. You can fine-tune them easily within Cortex. And then also, if you are, if you are low-code, no-code user, and you don't have a lot of comfort or experience using models, you could use one of our task-specific functions. So things like sentiment analysis, translation, those types of things can be done easily. You are interested in that. So that's the bottom layer. And then what we are hearing a lot from our customers is they want to actually make use of the enterprise data. And the way they want to do that is in 2 forms. They have structured data and unstructured data. So for each of those, we have specific products. So we have Cortex Analyst that's going to help you go from natural language, English, to an answer by writing SQL. And then we have Cortex Search that helps you go through your unstructured repo of documents and surface the right results. We'll get into that in a second. And then the top layer is the Cortex Studio. This is where you can come and play with different models and kind of get a sense of what models you want to choose, for example. It's a no-code feature that we have. And on top of all this, we have also built a couple of experiences for you. So we have Snowflake Copilot, which takes natural language and writes SQL for developers. And then we have Document AI that can extract values from your documents and put it in a tabular structure so that you can then start running analytics on it. So that's kind of the high level of Cortex. And it's easy and efficient because we have created a bunch of tools for you to use. It's all out of the box. It's fully governed. It's fully serverless, things like that. Okay, so then let's get to the third point, which is Snowflake is trusted. And the way you think about this is, we want to make sure that your data doesn't leave the secure perimeter of Snowflake. So we always make sure that your data stays within Snowflake, it's secure there. We also offer you very granular role-based access control that you can use on your models, on your data. In fact, you can even use it on specific AI features. And then, all of this can be used with this unified governance that I was talking about earlier. And then the only other thing I want to call out is LLMs, large language models, are interesting. They will give you an answer if you ask them a question. And sometimes that's not what you want. So for us to minimize hallucination and also make sure that AI is being used safely, We also use this thing called Cortex Guard, which is using Llama Guard under the hood so that if you're asking a question that should not be responded, it will stop answering. Okay, so we have all of these features and functionalities. You must be wondering, how am I going to make use of all of this, right? So let's get into some use cases that we have been building towards. So there are 3 main use cases that we are hearing from our customers. The first one is all about automating your BI. Think of it as analytics. The second one is all about conversational assistance. Think of this as a way for you to go through your repo of documents very quickly and find the right results. And then the last part is, pretty standard LLM use case, text processing and summarization. This could be batch text processing, or it could be on demand. So let's start with the first one, the automated BI use case. And I'll walk you through how we think about automated BI and the features that we use for it. So for the automated BI use case, we rely on Cortex Analyst. Now, a lot of people were raising their hands when we were talking about SQL earlier. We know that using LLMs to write SQL is a difficult problem. There are many different tables. The tables have a lot of different columns. Sometimes the names are different. It creates a lot of issues when you're trying to use large language models to write SQL. It's a very challenging problem. But at Snowflake, we see 4 billion queries every day, and this is the exact problem we want to solve for our customer. And the way we do that is through Snowflake Analyst. So the way this works is, we are thinking about how can we democratize everybody in an enterprise to start making use of their data. And if we take a step back and think about it, a lot of the business users may not be comfortable getting into Snowflake, or they may not need to get into Snowflake. So how do we enable them to start making use of the rich data that they have very quickly and make business decisions? That's what Cortex Analyst does. So the way it works is we provided a semantic model, and by providing the semantic model, it has the information that it needs to give you the right answers. And the entire flow here is you would have a question from a user in natural language. A Cortex Analyst will write the SQL. It will then execute the SQL, and it'll give you the answer as well as the SQL that it used to generate that answer. What's also interesting about Analyst is if you have an ambiguous question, it will not give you an answer. It will tell you how to improve your question and make it more accurate. So it kind of has that built-in feature as well. And with all of this, you can get accuracy up to 90+% with your SQLs. It's fully managed service, and it has high accuracy. And the other thing is it has the REST API. So if you are trying to build something, an application that you want to use this for, you can easily use that by integrating it with the REST API. So the use case that comes to mind is Bayer, which is a global life sciences company. They've been using Cortex Analyst to kind of go through a lot of their dashboards and replace some of their dashboards with Cortex Analyst. So what they can do is, instead of having a static dashboard, which is hard to maintain, the data team has to spend a lot of time kind of keeping it up to date, things like that, they have now shifted to Cortex Analyst, and they have this chatbot. They can use that to quickly ask questions and get answers for their business users. So that's the first use case. Now let's think about how we can make use of the unstructured data at the enterprise scale. So for this, we are going to look at Cortex Search. And Cortex Search helps you build enterprise-grade search and RAG applications. Okay, it is a hybrid search. And what I mean by that is it uses both the semantic search as well as the keyword search. So if you have a vector search or semantic search, you will also need to vectorize your question, and that way it can match it. And then the keyword search will help you get the exact search as well. So when you put these two things together, you have now given it the exact word that you want to search, and you've also given it the right context, and it combines those two things. It then goes through a fusion and reordering algorithm to ultimately give you a set of results in a ranked order based on this hybrid search. So, we have seen from our customers time and again that using hybrid search is more accurate than using just the vector search. So that's how Cortex search works. The beauty is you don't have to worry about fine tuning or your model and things like that, because you can improve its performance by just the nature of Cortex search itself. So for example, you can provide signals such as how popular a specific document is, or when was it last open, to help you get better results. And then once you have all of this, think of this as the retrieval part of the RAG application. So this is helping you retrieve the right type of data for RAG. And then if you want to build a RAG application, all you need to do is take all of this, pass it on to, remember the bottom layer where we had models? Choose the model, pass it through that, and you'll get your RAG application. So that's how Cortex search works. The story that comes to mind is Medtronic is one of the customers that's using Cortex search. And Medtronic makes a lot of life-saving medtech devices. So you can imagine they have a ton of suppliers globally. So when they have to go through contracts for suppliers, it's like 90, 100, 200 pages long, and they're trying to identify specific information from these contracts. They use Cortex search to quickly surface those and become more efficient. And then finally, the third use case is around text processing and summarization. There are two pieces here. We have Document AI, which I was referring to earlier. You can use Document AI to extract specific information from your documents and put it in some type of tabular structure to then do analytics. And then we also have this bottom layer with models and embed functions. So let's talk about that for a second and see how we can use, how easy it is to use this within Snowflake. If you were to use this in a Snowflake console, it's going to be all about using a single SQL function. So the first thing you will do is you will need to choose a foundation model. So you can do that using a complete function. I know we'll have a demo soon to see that. Once you have called your model, in this case we called Snowflake Arctic, which is one of our own models, but you could call any of the other models I was talking about earlier. Once you have that, you can then give it a prompt. In this case, I'm asking it to summarize my data in JSON format. And then you just have to point at the table or the data that you have. And it's just as simple. You can use it with SQL, Python, and we are also building REST API that's coming soon. And if you want to fine-tune your models, you can also do that serverlessly. You can currently fine-tune Mistral and Meta models within Snowflake using, again, SQL, Python, or our own AI/ML Studio. And then once your model is trained, you can register it, and then you can start using it like any other model that's available in Snowflake. So that's how we think about generative AI at Snowflake. I know this was a lot of slideware and marketing, so we'll get into the demo and kind of help you understand how this all works, and then we'll answer any questions that you have. Thank you.
All right, hello everyone. Two tough acts to follow, so I'm gonna try to not keep you waiting and be able to good followers to AJ and Aaron. So today I'm gonna demo basically two demos, one for Cortex Analyst and one for Cortex Search. And full disclosure, it's a well-known fact in demo world. If any of you have given demos, it's anything that's supposed to go wrong will go wrong, so bear with me. All right, so if you're not familiar with Snowflake UI, this is what we call Snowsite. On this side, you can do search on your everything, documentation, data, anything. You kind of organize your projects here, worksheets, notebooks, similar to Jupyter Notebook, Streamlit apps, dashboards, app packages, and your data here. So let's start with Cortex Analyst. So as you heard, Cortex Analyst is kind of an idea to give a very reliable version of Copilot. So if we go and open here, you kind of see Ask Copilot on the corner. And this, you can ask basically anything from your LLM about your data documentation. But this will give you answers about like 80% accuracy. How can we get that above 90% accuracy, which is very tough with LLMs. LLMs can hallucinate or famously not reliable. Let me first show you how this works. Let me just start the app. So this is a Streamlit app hosted on my local machine. Starting, take a few seconds to start the Streamlit app, and when runs, hopefully, as I mentioned, something will go wrong. Usually it doesn't take this long, but let me actually go back and go through, while this is starting, explain some more about what's happening here. For the sake of this demo, I've gone ahead and Cortex Analyst demo. I've uploaded, basically how you upload files to Snowflake is you put them on a staging environment here. So I've added these 3 CSV files plus a YAML file, and then organize them into these 3 different tables. So you have daily revenue, and here's a sample of your data. So I want to be able to actually just conversationally ask questions about this data. And that's the purpose of Cortex Analyst, which oh, I know what's wrong. It's waiting for me to give permission to connect. Give me 1 sec. Approve, all right. There we go. So, I don't have any idea about my data, so let me just ask what questions can I ask? And then based on the data that I have, it'll suggest some questions, and I can just click on them. I don't have to even type them. So what was the total daily revenue last month? Let's just try this one. And then it'll actually give me that number, and you can take a look at the SQL query that it's created and verify that it's actually valid. So yeah, this is kind of how it works, but let's kind of take a look under the hood. So if you basically look at the Streamlit app that's running it, it's very, it's not many lines of code. It's only 126, and most of it's just Streamlit placeholders. But the meat of the app is in this function, send message. It's just a very simple call of an API to Cortex Analyst. So I pass my semantic model file, and this is very essential. You need a semantic model, as Arun mentioned. And you call the analyst, and then you get the message back. If I do a good job, it'll all seem magic, basically. It's very straightforward, and you just call the API and pass the semantic model. And let's take a look at the semantic model as well. This is for the data that I have. Right now, you kind of have to manually create this, but we actually have an app that will come out soon. It's a Streamlit app that will automatically create the semantic file for you of your data. So you kind of just give a definition of what tables you have, what columns there are, and are there like tied dimensions or other dimensions or measures. And you might also consider giving it some sample verified queries, and then it'll use these to make sure that it's giving you valid results. So that was it for Cortex Analyst. And let's take a look at the Cortex Search. And for Cortex Search, actually, I'm going to show you of a version of Streamlit app that's being hosted on Snowflake. So you have two options with Streamlit apps. You can use the way I showed with Analyst locally, running in localhost, or let's go to projects, Streamlit. And Streamlit apps in Snowflake are very easy to create. It's just a click of a button. You Streamlit app create, and it'll create an app with placeholder code, and you can remove them. But let's start with Cortex Search app. And this is more reliable. It doesn't wait for my permission. It's just creating it. But as you remember from the presentation Arun gave, this is for unstructured data. So Analyst was for structured data. And by unstructured data, let's again go back to Cortex Search, my data. Under table, I've already chunked those, but what's essential are my docs. And I've uploaded these files, set of PDF files here. And what I do then is, let me go back to worksheets. And worksheets are kind of, you can create, let me see, you can either create SQL worksheets or Python worksheets. This is an example of a SQL worksheet. So I've created that database and schema. It's very easy. Then I created a function called PDF text chunker. This is a Python function defined in SQL that will chunk those PDF files for you. So I've defined that. Then I create that table, and then I call that PDF text chunker to chunk my PDF files and put the chunks in that table. After doing that, this is the other. So there are two main parts to Cortex Search. One, creating that service, and then calling and using the service. So after you've chunked, again, it's a very easy SQL call. Create or replace Cortex Search Service. And I give it this name, CC Search Service CS. And I specify, let's take a look actually on that table of data that I showed you. So I've chunked those into this table. And let's take a look at the table. So I give it the relative path, which file does that chunk comes from, what's the size of that file, file URL, scope file URL, and the chunk itself, and the category. The category actually was null. I've populated. I'll show you how I populated it. But this is basically the chunk is where I want my LLM to use it to get the data. Okay, so let's go back to the worksheet that I just showed you. So here, that chunk column that I showed you, I call the search service on that chunk. So what happens is it goes and takes that column, embeds it, vectorizes it, stores it, and a lot of magical things happen actually. It does then, whenever you call it, it does two kinds of searches. As Arun mentioned, it's a semantic search and a lexical search. And then another model comes in and re-ranks those two searches, and combines the results and returns it. And then you can do whatever with that. Actually, you're not limited to create RAG apps if you're familiar with RAG apps and LLMs. You can actually, I've had customers who used it to replace OpenSearch and Elasticsearch because it's a much more reliable fuzzy search compared to older Elasticsearch technology. And it's very fast. It can scale up to, we have had customers up to 200 million rows of these chunks of data and latency under 300 milliseconds. The other cool thing about it is the target lag. You can set a freshness. So this is 1 hour. I can set it to 1 minute. So that means is whenever there's a new data added to your table, it'll update that index. And the freshness will be within that 1 minute or 1 hour. So depending on how fresh you want to keep your index. Okay, so let's go back to the Streamlit app. And so basically, let's see, what kind of questions can I ask? What is the name of the mountain bike. I think this might be valid. Okay, so actually this is good because the mountain bike wasn't mentioned in the bike guides that I had here. So the good thing is it prevents the model from hallucinating. And another thing to show you is you can kind of select which model you want the Cortex search to use and answer your question. So you have Mixtral, Snowflake Arctic, Mistral Large, Llama models, Rika Flash. So you can choose any of them. And then you can also, let me actually call this again. All right, I knew there was something wrong. So it didn't answer because it didn't have that context. When I checked this box, then it's actually using those documents and is returning the name of that bike now. All right. The other cool thing about this is you can have access to the source code of this right here. And let's take a look on a couple of interesting things that's happening. So there is, let me just close these. So get similar chunks search service. This is my service. So I've defined the service as Cortex search service and the name that I had given the service. So I created basically a variable that points to my search service, and then I can call it anywhere. So I can call it here. I gave it the query that I want. Basically, it is the prompt that came back. So I call the prompt, and then I call it on search, and it goes back and retrieves the relative chunks for me. And then uses those prompt context to create that prompt. And then the other cool thing is this magic here. So Snowflake Cortex Complete is the function in SQL, and you have the equivalent in Python as well. It gets two parameters. The first one is your model name. And as I showed you, you can pass it to any number of those models that I showed you. And then you pass it the prompt, and you get the results back. Now, the challenge is these kind of chat bots don't have memory. So if I ask a question about this name of this bike, like if I, it actually doesn't, it's not even a chat phase. It just has one prompt. So if I ask anything about it, it won't remember it. What if we want to actually make it a memory chat where it remembers what I asked before and it uses that to answer questions? So for that, I can use some of the aspects, some of the features of Streamlit, where you can keep the previous prompts in the Streamlit chat and combine it actually with the chunks and pass it. Okay, this is really cool. I'm gonna show you what I mean. Always easier to show rather than tell. Okay, so I get chat history with this function, but then what I do is I say, based on the chat history below and the question, generate a query that extends the question. So let's say I wanted to ask about that bike. What is it? How do you repair it? How does the app know this it refers to? So it'll use that prompt from the context to create a new query that then passes to Cortex Search and retrieves the relevant data. And for that, this time in this version of the chat, I actually have used the Python version of it, which is from the Snowflake ML package. So if we look at under packages, I have Snowflake ML Python, and there you can have access to all these Cortex LLM functions and use them either here, or if you are more familiar with like Jupyter Notebook or any other notebook environment or your Python, you can use it that way. And that's it for the demo. Thank you. And almost nothing went wrong.
So if people have questions for Arun or Octane, yeah, we'll take a, I think I saw your hand first. Tim?
So I got a question. So you guys have a horizontal product, right? So you guys can do a lot of different use cases. I saw that you guys also spend a lot of time in financial services. I spend a lot of time in financial services, and right now we're doing a vertical. And so my question is, I'm thinking about potentially seeing you guys do a lot of this stuff for us. There's companies like Heavia and a lot of these legal, like these other guys, and they're sort of going down deep, right? But you guys also have that sort of summarization and sort of, looking through mass documents. Like, is there that much in the longer run, right? You guys can build a data room. Like, for example, if you guys wanted to build a data room and compete with Intralinks, you could do that, right? It's not that hard. You do a search, and that's the next generation data room. Like, would you guys compete directly with the verticals? I mean, is that kind of, is your stuff going to get good enough that there's no need for these verticals?
Do you want to repeat his question?
Yeah, so I think you're referring to the fact that Snowflake creates all these horizontal products, and what if, like, in each sector, how can we compete with that sector's special players? I will give you my own opinion. I don't know if Arun or anyone else here has an opinion on that from Snowflake, but I think one of the cool things that we have developed in the past year is our app marketplace. It's kind of similar. I think there's been comparisons to Databricks in the past, that in the way that Databricks is like Android and Snowflake is like Apple, where we manage everything, we make it very easy to use, and it's a nice product where it's easy for anyone to use. I think in that aspect, our app marketplace is similar to App Store. We don't have to, we create the tools, but we don't have to create everything that everyone needs, and we can't. So that's where our app marketplace comes in. And there are, I can actually, give me 1 second, I'll show you what I mean. For some reason, my Snowflake went dark mode. But here in apps, we have partners who have created apps in different categories. And it's all managed in Snowflake, and it doesn't, like, your data doesn't leave Snowflake premises. And so this is one answer, but I don't know if that's the only answer. I don't know if.
No, so they're using you guys, and they're basically fine-tuning and there's rules based on top of it for specific. And but as AI gets better and better, this is the question I'm going to ask them, right? As AI gets better and better, right, the next 3, 4, 5 years, as exponentially gets better, is there really, are there really a need for these guys in the long run? This is an interim solution because your stuff is getting pretty good, right? So and I'm going to ask this question because let's say I'm a Citigroup, and someone like Heavia comes and says document searching for trading or for virtual data rooms or for all of these different type of use cases. That's great. I'm thinking, well, why don't I just have you guys do it, and I have my applications guys build a few things on top. Is that me building my own CRM, or is that ultimately with AI, I'm not going to need that. It'll be smart enough for the next 5 years. Do I really need to fine tune it in the long run?
My answer is, I don't think we can really predict what will happen. There are possibilities that will happen, but it's also possible that we might still be improving our LLMs and kind of outsource the specific cases to individuals. To either you can use those apps or use our tools to build the apps for yourself.
Yeah, and the only thing I would
That one doesn't work. So.
the only thing I would add to that is the phase we are in right now. We want to create these horizontal use cases, and what we are hearing about is about these 3 use cases that I described earlier. As things get better in Gen AI, as we get better at all the different verticals, I can see a world where we have very specific models and tasks for very specific industries. But that's down the line. For now, we are focused on helping our customers. We have more than 10,000 customers from different verticals, and these are common use cases we are seeing across the board.
I think I saw you earlier. So when we do 2 more questions, just because it's getting late, and then we can break up and you can bombard these guys with questions in smaller groups. The question was, is the search end-to-end encrypted?
As far as I know, yes. We have, so first of all, nothing leaves Snowflake premises. But inside Snowflake premises, we have Cortex LLMs, we have Cortex basically clusters, our GPU clusters. And between those, it's, I think, MTLS encrypted between each part of our product.
I think maybe.
Hi, I remember, if I'm correct, Cortex can connect to different data sources rather than this Snowflake. So I wonder, how do you want to charge? Is it like GitHub Copilot, that kind of model? Oh, yeah, that's the first question. And the second question is, how do you evaluate your service, like the assistant or the search?
So the question is, when we are calling Cortex functions and Cortex search on outside data, that was what was the second part?
How do you charge the customer? What's the revenue model?
First of all, I doubt that you can call Cortex search on outside data. Like you can, for example, when you're developing your Python, you can use this Snowflake ML Python and import Cortex and complete function, for example. And you can call it, pass any prompt to it. So that's basically your data. It's not stored in Snowflake. That's your prompt, and you're calling a model. But outside of that, if you're doing like these massive amounts of data, it would make sense to store it in Snowflake rather than because every time this will, I think Snowflake's core value, one of the values that it brings is your data doesn't move. You can apply all these models, all these things directly to your data, and that you get from that a lot of performance boost.
Yeah, and just to add to the second part of your question about pricing, it's mostly token-based, but we have a whole section on our website that'll walk you through the pricing. It's a little bit different between Cortex Analyst and Cortex Search, just because of the nature of the operation, but all the information is available and is fully transparent.
Yeah, well, there's quite a few. So maybe what we'll do is, first of all, I just want to thank all the speakers and thank all of you for coming tonight, and Airbyte, thank you so much. So if you have questions, feel free to, as long as these guys don't have to, get home to their families and stuff, but feel free to come up and, ask some questions and stuff, but we'll just officially wrap for now. But feel free to, hang out for a bit and talk to folks. Thank you.